Oh, hello. Didn't see you there. Since you're here, let's talk experiments. Get out your spiral notebook. Make sure that you're looking at the table of contents. This is what we should have so far. We have weeks 1 through 4 all in here, and in case you didn't get some of these written down from week 4, I hope you wrote down your work for your standard 5 assessment. That certainly would have helped you get a better score. So this is what you should have for week 4. Today I am going to skip a space and get started with the stuff we need for week 5. So what we are doing right now is we are doing the page called Run an Experiment. I'm going to help you set a few things up, but a lot of the stuff that you're going to do on this page will end up looking different in the results than mine if you do it yourselves. But this is going to take us to page 20, so make sure you get that put on your table of contents. Run an experiment. We should be all the way on page 20. We've done so much great stuff this 4th term. And then I'm going to flip all the way to page 20. And of course, I'm going to go down in the corner and I'm going to write a 20 down there so that I know what page I'm on. So this is page 20. I'm now ready to put my title on the top. And remember, at any point, if I go faster than you, it's okay. Just pause the video and come back. So I'm going to write my title up here. Run an experiment. So the first thing I need to do, I'm going to give myself my own materials here to work with and run an experiment. I want to spin a spinner, but I don't have a physical spinner in front of me. So we are going to draw one. So I have just a little, this is an IKEA plastic cup. You don't have to have this specific cup, but you need something that is a circle. And you'll see as I put this on here, I'm just going to trace the circle and I'm going to trace it way over here on the right side of my paper. And this particular circle actually goes from that top blue line down about 11 spaces here. I think it was 11 when I traced it. Yours does not have to be this exact size. So right now you might need to pause the video and go find something circular about this big. It could be a little smaller or a little bigger, but if you're way off from this, if you have a circular candle and you want to put the base of the candle down, any old cup or mug will work for this. So pause the video, go find something circular that you can use to trace it. Pause and go. Did you find something? Okay, so place it with me over here, all the way. Get it as far over, it's hard to see on this side, but you can see I've got it almost all the way over to the edge of my paper here, and I've got it where it's gonna start about on this top blue line, so I can kind of see how big that is. So I'm placing this here, and then I'm just gonna take my black pen, you can use a pencil, pen, whatever you've got, and just trace around your circle. It's just because we all know circles are tricky to draw without some kind of template or tracing tool. So I am just tracing this circle. And this is going to be the outline of my spinner. Now I'm just gonna try and keep this simple because as far as our experiment goes, it's really important that we try to make these sections equal. So I'm just gonna cut this into fourths and try to make them as equal as I can. This direction I think will be pretty easy because look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces. Half of that would be 5.5. So 1, 2, 3, 4, 5. I'm gonna try and draw a line halfway through those. And I've even got a ruler here. If you have something you can use as a ruler or a straight edge, it'll make it a little better. If not, just draw it the best you can. So I'm gonna draw just a line across here. Went over a little and didn't quite get halfway. So I'm just gonna pretend that I meant this to be a little thicker line and go with that and call it good, okay? So here I have cut my spinner into 2 sections, but I want 4. So another thing that I can do to try and make sure, because this direction's harder to tell exactly where the middle is. So one of the things that I can do is measure how big this line was. This line, which would be the diameter of my cup, is about 7.7 centimeters. So actually, if I take my ruler this direction, and again, you can just eyeball this to the best of your ability, but you do want to try and make 4 equal sections. So obviously, if I'm over here, that is not, that's too small because that's 7.5. So I'm just going to kind of slide over to what looks like the middle, and I'm gonna measure, look at that. That looks about 7.8 maybe, so I'm gonna come back a little bit, 7.7. I'm gonna say that is about the right length. We'll see how this looks. Those 4 sections look about equal. I'm gonna make this one nice and thick too to account for any errors, just like I did the other one. So I am just going to write, look, I've created a circle with 4 equal sections, and I'm just gonna number them. And because you guys all know how much I like colorfulness, I'm gonna number them in 4 different colors. So I'm actually going to write a 1 over here, and then with that same marker, skip a space here, and I'm gonna write a 1 over here in green as well. And then I'm gonna use red, and I'm gonna write a 2, and then skip a space here and write a 2 in red over there. And then I'm gonna write a 3 with blue, and then I'm gonna skip a space and write a 3 over here. And then I'm gonna write a 4 in orange, and then I'm gonna skip a space and write a 4 in orange over here. Now to tell you what we're gonna do with this, I'm gonna write up here that I'm going to spin 50 times. Yes, you heard me correctly. I said 50 times. I'm going to spin the spinner 50 times. This is my actual experiment. It's called an experiment because I'm actually physically doing something here. I'm going to spin the spinner. Now you might be looking at this going, Ms. McGowan, you're crazy. How are you gonna spin that spinner? There's no actual spinner, okay? So you'll need something to help you actually spin. So one of the really common simple things to use is a paper clip. So I have a paper clip here. You can, and I have the lovely Adeline here who's gonna help me spin, but if you put your pencil on the center of your spinner, go ahead and flip that, Adeline. Flip it harder.
Yeah.
Like this.
Okay.
Try it again. You're fine. It's a little tricky. It takes a little getting used to. But you can actually then flip that paper clip just like you would the actual spinner part. So she just spun that and she got a 3. So I'm going to put a tally mark next to the 3. Now, actually, if you don't have a paper clip too, I found that this is a bobby pin. Bobby pins work okay because they have that little, anything really that you can take and hook onto your pencil, you can then flip it and spin it. So one more time, Adeline. Okay, she got a 2 that time, so I'm gonna mark it. Now I'm not gonna make you watch all 50 times, but this, what was easier, do you think, to the paper clip or the bobby pin? Yeah, I actually think the bobby pin's a little easier to flick it like that. So she's gonna do it a few more times, but you can do this all yourself, but it can be easier if you find somebody to help you and maybe one of you spin and one of you tally. So spin it a couple more times for me, Adeline. You got another 3. Oh, do that again. Oh, we got a 4. Keep spinning a couple more times. No, spin it really good.
Oh my gosh.
Yeah, that's a good spin. Ooh, barely in the 4. Oh,
Sorry.
a 3. A 1. So we're gonna keep spinning. I'm actually gonna pause the video, but I'm going to spin it 50 times and I'm gonna keep telling my results. I want you to do the same with your spinner. So you will pause the video here, just like I'm going to. You'll pause the video, you'll spin it 50 times, and you'll record your results over here. And when I come back, they might look different from my results. That's okay. They don't have to be exactly the same. But keep spinning, record your results until you get 50 total. So you're gonna pause and spin right now. Pause it. Ta-da! Here's what Adeline and I got. She's kept spinning and I kept recording and tallying up. So I'm just gonna write off to the side here. I got 5, 10, 14 times I got a 1. 5, 10, 14 times I got a 2. 13 times I got a 3. And 9 times I got a 4. Now, just to double check, I'm gonna add those up. 14 plus 14 plus 13 plus 9 is 50. So let's ask ourselves, so that's what we did. We actually ran the experiment. Now we're gonna write down a few questions. Now, first of all, these values here on your paper, if you actually paused the video and tried this, then these values, do you think they're exactly the same as mine or different? They might be close, they might be totally different, okay? So your results might be different than mine, and that's okay. So the first question I want you to write down, this is an important vocab for us, is how many trials did we run? And this is an important word when it comes to an experiment, because trials simply means how many times did you do it? How many times did you run the experiment? And I'm going to underline it in green and answer the question in green. How many times did we do this? 50. We did 50 trials because we actually spun the spinner 50 times. So that's the trials. How many trials did you run? 50 trials. Okay. So the next question we're going to ask here, number 2, and this is an important question as far as what this experiment actually shows us. So question number 2. Now, I know, and I'm going to say how many times did you spin? Let's go with spin a 2. Now, I know that the answer just as a frequency is 14, but actually what we can do is we can also consider this a ratio. So I want to know how many times did you spin a 2, and you guys are going to figure out for me, and I'll show you my results, but when I say a ratio, that means we can write it 3 different ways. We can write it as a fraction, and I can tell from looking at your probability stuff from last week that we need a little more practice and review in this to remember how this works. We start with a fraction, and then we move to a decimal, and then we can change it to a percent. And these will be a little different representation. Yes, I know I got 14, and I'm going to use red since I'm talking about the number 2. I know as far as how many times did I spin a 2, I got 14. And so this part, your number might be different because you might not have gotten 14. I got 14, but 14 out of what? 14 out of 50 spins. And yes, that's something that can simplify if I want to. I could put it 7 out of 25. Okay, but 14 out of those 50 spins gave me the number 2. So now it's not just a frequency of 14, it's actually a ratio. I'm considering this a ratio. It wasn't just 14 times, because that would very much change my thinking if I'd spun the spinner 14 times, saying I got 14 2s, that would have a very different meaning than doing it out of 50 times, or even doing it out of 100 times. How many trials you do it out of changes the meaning of your experiment. So I got a 2 14 out of 50 times. Now, how do I change that to a decimal? I don't necessarily think we all forgot how to do this on our probability work. It just seems that some of us didn't pay attention to which one was being asked for. Watch that really closely. Is the question asking you for a fraction, a decimal, or a percent? And make sure you type it in the correct way. So I'm going to type in my calculator 14 divided by 50, or I could totally do 7 divided by 25. But always remember it's the top divided by the bottom. So 14 divided by 20 says 0.28, and as you guys always notice, I put the 0 in front to really make it clear that it is a decimal. So I could write this ratio as 14 out of 50, or I can write it as a decimal. I got the number 2, 0.28 of the time, which if I times by 100 means I got the number 2 28% of the time. Now, technically, if you think about this, how much should I have gotten the number 2? Well, if there's 4 sections, shouldn't I have gotten the number 2 25% of the time? And we'll add some vocabulary behind this as we go, but that's fairly close. But it didn't turn out that way because probability is, as we talked about, it's just how likely something is. It's not necessarily exactly what's always going to happen. So I got the number 2 14 out of 50 times, which is 0.28, which is 28%. Okay, makes sense? All right, one more question on this, and here's something useful we can do once we have this information, is let's say, based on my experiment here, let's say, what if you spun it 1,000 times? I don't really want to do it 1,000 times, but let's take the information that I got here from running my experiment. If I spun it 1,000 times, how many times would you expect? So how many times would you expect to spin a 2? And the nice thing about finding this ratio here, I can use the fraction or I can use the decimal. Now remember, in mathematics, the percent is really useful. We find the percent because in society, percent has a lot of meaning to us. We know it's out of 100. It helps us compare everything. But please remember, like we talked about in class, you cannot do the math with a percent. It won't make any sense. The percent is something we use to help interpret things, but don't do the math with a percent. You have to do the math with either the fraction or the decimal. What math am I talking about? Well, it's as simple as saying, okay, if I know my decimal, and I like to use the decimal, it's easy to type in my calculator. If I got 0.28 or 28% of the time, I can times that by my new total, 1,000 spins, and this can give me a prediction. It's not exactly what's going to happen, but I can predict that I would spin a 2 about 280 times. If I spun my spinner, according to the experiment I just did, if I spun my spinner and I got 28% of the time 2s, then I would expect out of 1,000, 280 times. So running an experiment allows you to find a ratio of how much something happened, and then you can use that ratio to make a prediction, which is how this all ties into probability. So let's run one more experiment. Okay, we got room on our paper, and why not? Can you guys find anywhere in your house a standard number cube or die? Has 6 sides on it. Pause the video for just a second and go see if you can find one. If you have any game with a number cube in it, pause right now and go find it. Did you find one? If you really don't have one in your house, you can just watch my experiment and write down my information. But if you have one, I'd love for you to actually roll the die yourself and get this information down. So we're gonna move down on our paper here. I'm gonna skip a line and I'm gonna write down here. We're gonna skip a line, I'm gonna draw another blue arrow, and I'm just gonna tell myself that I am doing one more experiment. This time, instead of spinning, we are rolling. And I am going to roll, how many times should we do this?
50.
We should do 50 times again?
Yeah.
What if we do 60?
Mm.
Let's do 60 times, just for fun. I am going to roll it 60 times. And Adeline's looking at me like, okay, because she's actually gonna roll it 60 times. And I'm gonna list these numbers down here so I have a spot to tally. I know my possible results are just 1, 2, 3, and I'm gonna use another column so don't fill up all this space. So I'm gonna go 1, 2, 3, and then I'm gonna go to a middle column here and I'm gonna write 4, 5, 6. And I'm gonna start rolling. Go ahead and roll first, Adeline, and then we'll start tallying our results. She got a 4, so I mark a 4. 2, mark a 2. You guys get the idea? We're gonna keep going. So I'm gonna pause the video. You guys pause the video as well and start rolling, rolling, rolling. Roll your little heart out, okay? Pause right now. We did it 60 times. So I tallied as Adeline was rolling, and I wrote my totals next to each of them, and then I added them up, and I actually got 62. We did 2 extra, so I took off these last 2. Those were the last 2. We got a 3 and a 6, so I just took them off because we wanted 60 trials, and I wrote that over here just to remind myself, 60 trials. We did 60 of them this time. So kind of think about maybe what should have happened. How many numbers are on a number cube? 6. And if I did this 60 times, technically I should have gotten 10 for each of these, just according to probabilities and in theory what should have happened. But when I ran an actual experiment, this is what happened. Okay, so let's answer a few questions. Now I already wrote over here how many trials we did. We did 60 trials. It's just always the total. Add up all those numbers, 60 trials. Sometimes, like on the MLE you're going to try next, you'll be given a table of somebody that already did an experiment, and if it says how many trials, just add up the numbers. Add up all the numbers. How many times did they do something? So question number 4, I'm going to skip a line here. Just to practice this idea of fraction, decimal, and percent, I want to know how many times did you roll? I don't know, which one should we do? How many times did you roll a 3? You could really pick any of them, right? And we could do this for all of them, but we'll just show an example with one. Now, obviously, I know that I rolled a 3 12 times. Yours might be different. You might have rolled a 3. It's probably something around 10. If I had to guess, it would be something around 10. Some of these were lower than 10, some of them were higher than 10, but probably something around 10. But again, we're going to focus on this answer not just as a frequency, 12 times, but 12 out of what? Because how many times you run the experiment will drastically change what that frequency means. So how many times did you roll a 3? Let's tell ourselves what that is as a fraction. Then let's tell ourselves what that is as a decimal. And of course, what that is as a percent. Okay, so how many times did we roll a 3? We rolled a 3, can you use the screen here, 12 times. Again, your number here might be different, but 12 out of what? 12 out of 60. That's really important. And actually that simplifies down nicely to 1/5. And you can type in your calculator 1 divided by 5 or 12 divided by 60. This is one that I have memorized, and maybe you do too. 1/5 as a decimal is 0.2. If you don't believe me, type it in your calculator to verify it. And 0.2 as a percent is 20%. So I got the number 3, or Adeline did when she rolled 3, she got it 20% of the time. Okay, so we can then use that, just last question here. We can use that idea, I'm gonna write number 5. What if you rolled the die, and again, I don't wanna do it, 60 times was enough, but what if you rolled the die, I don't know, 5,000 times? Again, I don't want to do that actually, so I'm gonna use my experiment that I already ran to make a prediction of what would happen. How many times would you expect, so how many times would you expect to roll a 3? I'm going to use my information up here to help me make a prediction. Now, a prediction, as we've talked about, it's not going to be exact, perfectly exact, but it should be a pretty good guess. I'm going to take my decimal, 0.2, and I'm going to times by this new number of trials, 5,000. If I do 0.2 times 5,000, you could type that in a calculator, 0.2 times 5,000, I get 1,000 times. That would be my prediction based on what happened in my experiment. I would probably roll it 1,000 times, roll a 3 1,000 times. So experiments, the new vocab here is just what is a trial? And then once you've run a bunch of trials to create an experiment, you use the information you got from that, turn it into a ratio, and answer some questions about it. That's what your MLE is going to work on today. So I hope you got all of this written down on page 20. Give the MLE a try. And of course, let me know if you have any questions. See you next time.